Chapter 9, Section 5 in the 7th grade note-taking guide is entitled Areas of Circles. So we've already looked at circles, but when we looked at circles earlier in Chapter 9, we were talking about the circumference of a circle. In the same section, we were talking about perimeter of polygons. Remember, circumference is the distance around a shape. Well, now we're talking about the area of a circle. So how much space a circle is taking up, how much space this two-dimensional space is taking up. So, start off here, probably most helpful to have a formula. Now, if you recall, when we found circumference, we had a formula for radius and we had a formula for diameter. We don't have that for a circle here. Circle is found by taking pi, which most times will approximate as 3.14 as we did earlier, and multiply that by the radius squared. Remember, squaring a number means taking it and multiplying it by itself. So if the radius is 3, we're going to take 3 and multiply it by itself. 3 times 3 would change into 9. Really easy. All right, so solving this out here, one other thing you might run into here is they might actually end up giving you the diameter, which of course, remember, the diameter is what you get when you go all the way across the circle here. Well, if they give you the diameter, what you want to do is go ahead and cut that diameter in half, and that's equal to the radius. Remember, the diameter goes all the way across, the radius is just half. So cutting the diameter in half will indeed give me a radius, which is exactly what I need here. Okay, so taking a look at 1A here, finding the area of the circle. Notice they showed it to me with a radius, so that's great. So it's 3.14 times 7 squared. 7 squared is 49, so this is the same as 3.14 times 49. And you can see we multiply that out and we get 153.86. So the circle takes up about 153.9 centimeters squared. 153.9 square centimeters of space. All right, let's go ahead and take a look at number 2 here. Number 2 says park employees are fitting a top over a circular drain in the park. If the radius of the drain is 14 inches, what is the area of the top that will cover the drain? Use 22/7 for pi. So here again, they're asking us to find the area. What's different about this question is they told us to use 22/7 for pi. They told us very clearly at the start of the second line here that the radius is 14 inches. So we're going to change r into 14. So it's 22/7 times 14 squared. Well, we simplify 14 squared, 14 times 14 into 196. But as you can see here, the reason they use 22/7 is because the 7 is going to reduce out with the 196. That's exactly the same reason we use 22/7 in the circumference section. If I was going to end up multiplying it by something that it would reduce with, that's when we would use 22/7. If you end up using 3.14, it's not a big deal. But they use 22/7, so we'll run with it. So if I write 196 over 1, which is usually how we reduce here, we would say on the diagonal is 7 and 196. I can chop 7 out of both of those. 7 divided by 7 is 1, and 196 divided by 7 is 28. Well, now I have 1 and 1 in the denominators, which is great, because now these are just both regular integers. I'm going to multiply. 22 times 28 is going to give me my area. So my area is 616. So the area of the top that covers the drain is about 616 inches squared. Now as we go on and take a look here at question number 3, in question number 3 here, they've given us, as you can see, a circle, and they've asked us to use a centimeter ruler to measure the radius of the circle. Then what we're supposed to do is to find the area of the shaded region of the circle using 3.14 for pi and rounding to the nearest tenth. So the best place for me to start is actually to go ahead and measure that line and chop it in half, because that's how I'm going to get the radius. Then we'll have to take into account the shaded part.